Look at your feet. Well, I know. I told you that yesterday. Remember, we did dance transversal last week. That's not notes. All right, so today is going to be our introduction to proofs. Okay, don't get too excited. I know. I hope you are excited, but go ahead and put those computers away. You guys don't need them out. So with proofs, okay, we're going to be kind of putting words to math. Okay, so just a heads up on that. But with proofs, what we're doing is we're just proving that something is true. So do you remember what was that one of those words that we learned in the first chapter? Well, we did learn hypothesis, but what was the word? It was one of our first couple sections that we said, like, this word means it is true. Yeah. Yeah, postulate, okay? So we'll be using something like that with those postulates, okay? But we're going to be given, today it's going to be algebraic proofs, and then we're eventually going to go into geometric proofs, but we have to prove why something's real. And just by proving by something's real, we have to go by those step by step. So it's like if you're walking somebody through step by step on like how to make a PB&J or something like that. You have to explain it in a certain way for them to make that. Okay, so with the proof, okay, it's an argument that uses logic, definitions, properties, and previous proven statements to show that a conclusion is true. Okay, so you can go ahead and write this down. All right, the beginning's going to have a lot, just a heads up. Okay, but with proofs, okay, the important part of writing a proof is giving justifications to show that every step is valid. So we'll see an example like that in a moment, but eventually we're going to get our properties written down first and look at those. I'm going to go ahead and zoom. Actually, okay, so I'll let you just finish that up real quick. Okay, and once you're finishing that up, okay, our next slide is going to have a bunch of properties. Hey, you guys should write notes. Our next one is going to have properties, okay? Some of these properties are going to be familiar, okay? But I still want you to write them down. It's going to have a table on the next slide. With that table, have room for one last one below because it's just for some reason not in this table, okay? So here's going to be an example of the properties that we're going to be talking about today. All these say addition property of equality. Don't write the of equality parts, okay? Just put like addition property or just put subtraction property. So just write those down and then put to the side an example of that. And again, I know you know what addition property means and subtraction, okay? But go ahead and write that down because we're going to be using that today. So you just got to make sure you're familiar with that. Mm-hmm. Yeah. Yep. We're gonna start this stuff at 4, and then match will start at 4:15. We play Scion, so it will be good matches.
Okay, cool. So it starts at 4.
Correct. Okay, I'll give you plenty of time to write those down. So just continue writing those down. All right, reminder, you do not have to write the of equality. All right, a reminder, there's still one more after this. After this, just one more. Okay. So with a couple of these, okay, addition, subtraction, multiplication, division, most of those should sound familiar, okay? You're just doing what it says. So if it says addition, okay, it's adding, subtraction, you're subtracting, and so on, okay? With the reflexive property, okay, it says A equals A. This will make more sense when we eventually have a an example like this. But this will kind of be more with triangles when we get to triangles. But like if I have this triangle that I'm writing on the board, all right, we're trying to prove that these two are congruent. An example of reflexive property is if I had this triangle labeled, all right, and we needed to say that our AC, like the two sides are congruent, we would say AC is congruent to AC. Okay, that would be an example of reflexive property. That will be further on when we go into triangles, but there's just an example of when we will use it. Symmetric property, that will be something like if we solve an algebraic um, proof, if we have something that says like if we are solving for x and we got 12 equals x, an example we'll use symmetric properties, we'll just do symmetric property and make that x equals 12. Okay, so our x is on the left. If we just need to flip our x and 12, then that would be using symmetric. Okay, transitive kind of just explains it right there. If a equals b and b equals c, then a equals c. Okay, and then substitution property, you're just substituting the expression. Okay, so if a and b equal each other, then b can be substituted. Okay, our last one is distributive property. I'm going to go ahead and move to that one. Okay, so this just states, okay, you're just distributing that a, so therefore ab plus ac is the same as a times b plus c. Yeah. Yeah, I'll go back in 1 second. Go ahead and get this written down. All right, get this one written down. If you didn't finish the last slide, I'll go back to it real quick. But go ahead and do that. All right. And this is the distributive property. Okay, and here's this slide real quick, just so if you didn't get that finished, then we'll move on in a second. All right, if you're not done, just look at your neighbors if you need to finish that up. Let's look at some examples, okay? So let's look at these examples right here. All right, we have A says if C equals D, then D equals C. All right, who thinks they know what property this is going to be? Yeah, what do you think, Jordan? Yeah, this will be symmetric property, okay? When we do these, if you want to just abbreviate, you can just do this, all right? And you can just write it as that. Put like the first three letters, okay? The biggest thing is you just have to pay attention to, like, if you're saying subtraction property or substitution, you do have to put a couple more letters, okay? Because if you just put SUB and then property, all right, then how am I going to know which one you're talking about? Yeah. Yeah, but we'll do practice with these that eventually you'll be able to, they'll come right to mind when you're doing them. All right, what about the next one? If Mn equals PQ, then Mn plus 7 equals PQ plus 7. Yeah, what do you think, Will? Yeah, we're just adding 7 to them, okay? So this will be addition property. Perfect. All right, yeah. Those are like saying sides or line segments. They'll be like typically lowercase, but we're not doing the algebraic part. You'll know when it's multiplying. Yeah, let's look at the next one. All right, it says if the measure of angle F equals 48 degrees and the measure of angle G equals 48 degrees, then the measure of angle F equals the measure of angle G. Which one do we think this is? Yeah. Not reflexive. Not symmetric. What do you think, Tanner? Yeah, this would be an example of transitive, okay? Because this is saying the same thing as like if A equals B and then B equals C, okay? A equals C. So this is transitive property. All right, what about D? It says Z equals Z. Which one's this an example of? Yeah, Julian? Yeah, that would be an example of reflexive property. Perfect. Okay. All right, are these, you kind of see how they're being put in place? So those are some examples right there that we have. Give me 1 second. Okay, I know this already shows a step, but let's look at this one. We're going to solve this equation right here. Okay, it's 4m minus 8 equals negative 12. All right, when we typically have proofs, we're going to write a box like this that I'm putting on the board. Okay, and what this is going to look like is we're going to have our reasons here. And oops, I think I mixed them. Sorry. This will be statements. And reasons. Okay. So this equation that we have first, all right, is 4m minus 8 equals 12. Okay. I know most of us should know just how to solve for m right away. Okay. But with this, we got to explain each step and what property we are using. All right. When we do a proof, okay, you got to remember the first step every time. The first step when proving is we need to put our equation. We're going to put 4m minus 8 equals 12. Okay? I'm going to put 1 here. My reason is given. We are given this. Negative 12. Sorry, thank you. My fault. Negative 12. Okay? Your first step is always given. If you're given the equation, so that's your first step. So when we do these proofs, all right, this should be the easiest points is just putting your given down. All right, you should never miss points on this. And there's like 2 easy points just by putting the given. So now when we're solving this, okay, what would our next step in solving this equation for m be? Yeah, Charlotte? Yeah, we're going to add 8 to both sides. Okay, when we add 8 to both sides, what property do you think we're using? Yeah, we're using addition. Okay, you can show that step here. Okay, but let's just put it as solved out. So if we have 4m, these 8's cancel out. What's negative 12 plus 8? Negative 4. Okay, so I'm just going to put that as my second step. 4m equals negative 4. All right, and we just did the addition property. All right, perfect. All right, it already shows our next step, okay, but we got to divide both sides by 4 to get m by itself. Okay, so what property do you think that is? Division. Okay, so that's perfect. All right, we get m equals negative 1. I'm going to put the m equals negative 1, and that was the division property. Okay, because all we divided, all right, if you wanted to put extra steps and say simplify in between, you're welcome to do that. So you can like show this right here. Okay, show that you divided right here. But it's also fine just doing this in like a more simplified version. Okay, I wouldn't count off if you did either or. All right, here's like another one. We're not going to write this one down, but we have solved the equation. Okay, half of t equals negative 7. All right, we have to write our given right away. So you just put that equation in. You put that as given as your first step. Okay, then on your next step to get rid of the half, we're going to multiply both sides by 2. So that would be an example of multiplication property. All right, and then we just simplified to get that answer. So really, this one could just have your given. It could just be written as this is your first step, t equals 14 is your second step, and say multiplication property because you multiplied both sides by 2. Okay, but it's always important to show your work on the side because maybe if you did one little step wrong, I looked to the side, okay, they did this right, they just wrote the wrong property, so you would miss just like half a point. Or if it was 2 points, you just miss 1 instead of 2. Okay, let's look at this. Okay, this one's going to be a little bigger. All right, let's look at this. We are given all our statements. We got to figure out our reasons. Okay, I'm going to zoom in just a little bit. So let's go ahead and look at this. All right, and some of these reasons, okay, are going to be simplified. Okay, that's why it looks so big, but we got to recognize that. Okay, so our first statement is what we're given, and our reason is given. Okay, perfect. It already gives us that. All right, who can tell me what is that next? How did we get from this to our 15x minus 10 equals negative 6x minus 6 plus 3? Yeah? No? Chandler? Yeah, it did the distributive property, okay? So that's going to be my reason, okay? Distribute, I'm just going to put dist property, okay? And perfect, all right? Now, what is it doing on that next step? Yeah. Yeah, it's just simplifying, because what did it simplify? What did it do? Yeah, it just did the negative 6 plus 3, okay? So this is just simplify. All right, and I'm just writing that down on the board. Perfect. Nope, because addition needs to be adding on both sides. Okay, what about the next step? What is it doing? It's adding 6x on both sides, okay, to eventually get x by itself. So what property do you think that is, Esme? Yeah, addition property. Perfect. Okay, and then my next step, it just simplified, so I'm just going to put simplify. Okay. All right, what about our next one? Okay, what is it doing? It's adding 10 on both sides. Okay, because we have negative 10 here. So then what property is this, Madison? Addition. Okay. All right, then it simplifies. It gets rid of those 10s. Okay, and then finally, what's that last step? Yeah. Yeah, it just does division property. Okay, and then finally gets our answer. Okay, and it simplifies. All right, so it would look something just like that. All right, do we have any questions on this? Or wondering how we're getting any of this? Okay, let's do this one on your own. All right. This one you're welcome to put simplify. Okay, that's why it has so many boxes. I'm gonna do an example of what it's like to not have simplify. Okay, so that way you just know what it looks like. All right. So go ahead and write this in your notes and work it out. Sorry. Yeah, we'll use like the box just like that all the time.
So on that last example,
Mhm.
it was like, so if I was subtracting like 2 from one side, so over here it'd be, the next step would be 3x plus 2 minus 2. Do I need to write that?
You don't have to.
I
You can just
what I
write
got
the,
out of it?
yeah. You can just write what you, and I'll write it on the board so you know what that looks like. Oops, I did not mean to do that. There you go. Sorry. All right, let's look at this one together. Okay. So on this one, all right, who can tell me what our first reason is going to be? All right, what did you say, Jordan? Yeah, it's going to be given, okay? Because that's always going to be our first reason. All right. Now, when we do this next step, okay, there's a couple different ways that you could do it. Maybe you started with the x's first. Maybe you started with the numbers without x first, okay? As long as you like do the correct work and get the correct answer, okay, then you're fine. And I'll check that and make sure you do those correct steps. But yours might look a little bit different from your partner's. All right, so let's say I started with the x's first and I want to move my negative 4x. If I'm moving that negative 4x to the other side, what do I need to do? Yeah. Yeah, I need to add 4x to both sides. When I do that and add 4x, okay, my next step can just be 7x plus 2 equals 23. All right, and what I did is the addition property. Okay? All right, so this would be a way you don't have to use simplification, and if I just erase that, then that's fine. Okay, now I got to move the 2 over. What do I do for my next step? Yeah, subtract. Okay, so I got to subtract that 2 over, so I have 7x equals 21. All right, and it's subtraction. Okay, I got to make sure I add that t. Okay, so I know it's subtraction and not substitution. So if you just put sub, all right, then that wouldn't be right. All right, then finally, what do I got to do? Yeah. Divide by 7. Okay, and I get x equals what? And that would be division property. Okay, so I know there's a lot more boxes, but that's if you want to add the simplifying. But you do not have to add the simplifying. Okay? Is this making a little bit more sense? Yep, if you subtracted the 2 first, that's fine. All right, and then if you added the 4x second, that's fine. All right, as long as you have those steps and you get that correct answer, you are good. All right, let's do this one. Go ahead and do this one.